Hello, today we are talking about the cell and its environment. This is also known as diffusion notes. You definitely need this for your Unit 1 test. So if you didn't get these notes last week because you were in quarantine, please take them on paper now and put them in your notebook when you get to class. Okay, so cells are like castles. Not because they have walls, because not all cells have a cell wall. They are like castles because they only let certain things in and certain things out. If you've ever been to the castle in Versailles, you'll notice there is a big wall around it and then another smaller wall. And the castle itself is pretty small. But you also can't just go. You have to buy a ticket, at least to that castle. So, as the picture says, the castle is closed to the public, no traffic beyond this point. And that is true. So the cell membrane is selectively permeable. You need to write what's in purple up top. The cell membrane is selectively permeable. That means that it only it only lets certain things in and certain things out. It's selective. It's permeable though, and that things can move across it pretty easily. So cells like castles must let things enter and leave. All cells must let in needed materials such as oxygen and food molecules. In contrast, though, waste materials must be able to move out. So I tell this story to gross people out, but also to help them remember that the cell wall is selectively permeable like a castle. So when I was in college in history class, I had to read this weird book, and I can't remember for the life of me the name of it. I got to find it when I get home. But in this book, towards the end, it's a normal book. It's really boring history book. It's not based on real life events. It's based on just history in general. So it's set in a historical time where there are castles. And in this castle, there are people who are hiding behind the castle walls because another nation is trying to take over. So they barricade themselves in and they don't let anybody in. But the problem is, by not letting anybody in, they run out of food. So all the royals are stuck here with no food. It's mostly women. The other people went out in order to fight. So then, over time, they become hungry and they decide to cannibalize. But instead of killing their royal families, what they wind up doing, now hang with me because this is disturbing, is they cut the buttocks, the bottom, the butt cheek, off of some of the women and eat that in order to survive. They drink their own urine, so on and so forth. And the other problem that they have is they can't let things out of the castle, so that winds up to fill up with waste, and it's quite disgusting. Eventually, they do all get out, but then they're forever known as the cannibalistic royal family. So we do need to let things in and out of our cells. Otherwise, our cells are going to build up with that kind of stuff and eventually die off. So, little things that can get in, some food molecules, amino acids, which is a breakdown of a protein, oxygen, things we breathe in. And then we need things to get out. So diffusion, this permeation is diffusion. It is like dropping in a drop of food coloring into water, and slowly that color takes up all of the water. That is diffusion. Another example of diffusion is when you spray Axe body spray, and you don't have to spray much, and then you can smell it throughout an entire room, or in my case, the whole house. And that's because it permeates the air. It diffuses through the air. All right, so what you need to write is what's in purple, diffusion, and then you're going to write below diffusion, substances that can move into and out of a cell do so by one of three methods. You have diffusion as an overall term of movement of particles, but also diffusion refers to, little d diffusion, refers to things that move from high to low, from where there's a lot to where there's a little. And we'll get into that in just a second. There's also osmosis or active transport. So take a second to write that. All right, if you're not done writing that, you can go ahead and pause the video, but I am going to continue on. You need to write the second bullet point down here. Let me get my mouse up. You need to write this. Diffusion, up here, this is important, is the main method by which molecules move across the cell membrane, but it's not the only method. So diffusion, defined, is molecules that move from an area of high concentration to an area of low concentration. What does that mean? Well, concentration is how much stuff is there. So if you wanted to move from where there's a lot of people, say you're in the classroom full of students, but you're feeling overwhelmed, you're starting to panic, you may move to an area of lower concentration out into the hall. And that's moving from high to low. So you do need to write that as a definition for diffusion. In fact, that's going to be a quiz question, and it was on your review. All right, pause if you need to. I'm going to continue on. What causes diffusion? Molecules always moving. The molecules move, they bump into each other, and the more there are in one area, the more collisions there will be. They continue to spread out, and eventually they spread evenly throughout the area. So please do write this whole slide. So I'm going to give you a scenario. We have a room full of toddlers. So many toddlers. And what toddlers do is they move all around the room. They move quickly. They'll run into each other and fall down. They cry. The more movement there is and the more of them in an area, the more collisions there will be. They will continue to spread out if they have the ability to. If the door is open, you better believe those toddlers are going that way. They can make an opening, they will, and they will spread out evenly throughout an area. They won't necessarily stick together. The more toddlers there are at school, at my daughter's daycare, the more likely she is of getting bitten, which she was bitten quite a bit a couple of months ago because she was in for that fight. And that's because there were collisions. All right, take a pause if you need to, and continue the video when you're ready. Osmosis. You need to write this right here. Osmosis is the diffusion of water molecules through a selectively permeable membrane. And then you need to write down here, water molecules move or diffuse from areas of high concentration to areas of less concentration. Many cells cannot function properly without adequate water. We need it for a lot of cellular processes. You don't have to write that bullet, but you do need to write the first and the third. And when we talk about high concentration to low concentration, what we're talking about is not necessarily the water, but the solute, the salt or the sugar. So here's our three examples. A hypotonic solution has high water and low salt. So it's hypo, low. It's below the amount of salt concentration as compared to the cell. And you do want to write that. Isotonic, iso means equal. The cell and the solution have the same amount of salt and water concentration as the other. So they still have an enter and exit of salt and water, but it's an equal amount. Lastly is a hypertonic solution. It has low water to salt concentration. So the water is less than the salt in this situation. And this is going to cause the water molecules inside the cell to be attracted to the salt on the outside. So the water leaves the cell and it causes shrinking. So the salt takes up more space, so the water moves out. So what I want you to see here is that we are talking about a movement of water, but the water moves because of the salt that is around, or the solute. So a hypotonic solution will swell like a hippo, cause the cell to swell. Isotonic solution is equal, it stays the same. And a hypertonic solution causes the cell to shrink because it's so hyperactive, it gets real skinny. All right, pause and finish writing. I'm going to continue. Next, we have passive transport. You're going to write what's in purple. But you don't need to write any of this just yet. So passive transport is talking about like a bicycle. If you ride downhill on a bicycle, you don't really need to use energy. It's going to go pretty fast and it's going to be easy. For a cell, moving materials by diffusion and osmosis is like cycling downhill. Doesn't require a lot of energy. So under this, I want you to write, sorry about that. Let me see. It doesn't give me that option, does it? Thought I could type. I'm not even going to try. Yeah, we will. Diffusion and osmosis is passive transport. No energy required. No energy. That's what you need to write. Because it's easy. It's simple. It's passive, just like a passive person. All right, clearing the screen. Pause if you need to. Active transport. Active transport requires the cell to use energy. If you have to pedal back up a hill, you're going to use energy pedaling up. If a cell has to take a substance that is present in a high concentration, it's going to use its energy more. So if it needs to get more and more stuff in its cell that it already has a lot of, it's going to require energy. So active transport requires the cell to use its own energy, while passive transport does not. Active transport is going to require the type of energy we call ATP. That's what the energy is. Energy is ATP. It means adenosine triphosphate. We're not quite there yet, but that is what it means. Okay. I just need to clear this section. Transport proteins. Some substances that are carried into and out of the cell, they need a transport protein, and that's because they can't get through. So calcium, potassium, sodium, which is, parts of salt, all these things can't get through. So a cell membrane may contain these right here. These purple things, those are transport proteins. Each transport protein can carry in a very specific thing. So you have diffusion. Whatever that purple dot is, it's moving from high to low concentration. So it just kind of squishes those two little things in the membrane apart, squeezes its way in, kind of like a mouse does into your home. You don't let a mouse in through the front door, but it comes anyways. It's small, it squeezes in. Facilitated diffusion, you're going from an area of high to low again, but you're going through a door. So you're allowed in your house, you can come on in. Active transport goes through this protein by going from low concentration to high, and you have to pay to get in. So ATP is then paid here. It's kind of like a little coin. And this would be kind of like going to a movie theater, because your movie theater is going to be packed, not very many people on the outside because they're trying to go to a movie, and you have to pay to get in. So with transport proteins, a cell membrane is going to contain these in order to get in. And not all transport proteins, like these two right here, use energy. Only an active transport protein does. But this purple thing there, that's your transport protein. Okay. So ready to move on. Clear this section. Pause if you need to. Why are cells so small? We actually didn't go over that just yet, and we will another time. Something else you're going to do is you're going to watch the video that was assigned with this. Skipping this. Hold on just a second. The other thing that you were... Oh, I don't want that app. Oh, I thought I could switch tabs. Perhaps I cannot. Okay, I can't switch tabs, but there's another video with this. It is an Amoeba Sisters. There was an assignment with it, answering questions. You do need to do that assignment. Part of it is a standards check. So please complete this and turn that in to me. Have a great day. If you have any more questions about